Somewhere beneath an icy moon or deep within a Martian crater, something might be alive right now, and it probably doesn't look anything like us. Welcome to Stellar Lab. I'm thrilled you're joining us for our very first episode.
That's right, today we're cracking open astrobiology, not just rocket ships and aliens, but the serious, scientific hunt for life beyond Earth. I'm here to help break down how scientists actually approach that question. Are we alone? And what does life even mean in the universe?
By the end of this episode, you'll see why astrobiology is so much more than sci-fi. We'll show you how Earth's weirdest microbes rewrite the rules of life, how we search for ocean worlds, and why the big question isn't just is there life, but where and how could it survive?
Here's the roadmap. First, we'll dig into the 3 core mysteries that define astrobiology. Then, we'll break down the essential ingredients for life as we know it, talk about the wild tools scientists use to search the cosmos, and, of course, wrestle with that classic question, the Fermi paradox. Ready to dive in?
Let's kick things off with a twist. Most people imagine life needs sunshine and a mild breeze, but Earth is absolutely packed with creatures living in scalding vents, acidic lakes, and crushing pressures.
What blows my mind is that some microbes actually thrive near hydrothermal vents at the bottom of the ocean, where the sun literally never shines. They survive off of chemical energy, not light, showing us life can start in places we'd never expect.
And that cracks open the universe, right? If life can exist in those insane conditions here, it means places like Mars, or even the icy moons around Jupiter and Saturn, might not be as lifeless as they look.
Exactly, the idea is, if water, energy, and the right chemicals are present, life might just find a way. That makes astrobiology this wild detective story, searching for those clues in places nobody thought to look before.
So, the whole field of astrobiology really orbits around 3 questions. How does life begin and evolve? Does life exist elsewhere? And what's the future for life on Earth and beyond?
I love how the first one takes us back to Earth's origins. Scientists peering into ancient rocks and deep-sea vents, basically trying to recreate the recipe for life from scratch.
Then there's the search for life elsewhere, like sending rovers to Mars to dig for fossils, or sending probes to explore Europa's buried ocean.
And that last question is where things get really speculative. How might life adapt to wild new environments, like other planets, or even space itself? It's not just about finding aliens, it's about understanding ourselves and our own future too.
That leads perfectly to the basic formula. What actually makes life possible out there? Scientists usually say it comes down to 3 things: liquid water, organic molecules, and a reliable energy source.
Water is the superstar, right? It's a world-class solvent, and while some dream of life in methane lakes or ammonia clouds, nothing beats water for sparking the chemistry of life.
Don't forget the biogenic elements, either CHNOPs, carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur, especially carbon, since it builds those long, complex molecules like DNA that make life flexible and resilient.
And then you need an energy engine, sunlight, for photosynthesis. Or, for the really wild stuff, chemical energy from minerals like sulfur or iron. What's cool is, by spotting these ingredients on distant worlds, we get our first real hints there might be life out there.
So, the next step is figuring out how to actually find those ingredients. That's where tools like spectroscopy come in, analyzing starlight from distant planets to see what chemicals are hiding in their atmospheres.
It sounds almost magical, but by dissecting just a bit of starlight, astronomers can spot water vapor, methane, or even biosignatures like oxygen, which could mean something is breathing or living there.
And we're not just looking for big, obvious animals. The first sign will almost certainly be something tiny, maybe a whiff of methane, or a weird chemical imbalance that shouts, "Life was here!"
That brings us to the big cosmic puzzle, the Fermi paradox. If life should be everywhere, why haven't we found it staring back at us? It's the ultimate question mark that keeps astrobiologists up at night.
Let's dig into that. The Fermi paradox basically asks, if the universe is so old and so vast, why haven't we seen any clear evidence of alien life? No messages, no megastructures, not even a cosmic postcard.
People have all sorts of theories. Maybe life is incredibly rare, or maybe intelligent civilizations self-destruct before they can reach out. Or maybe, just maybe, the distances are so overwhelming that even the closest neighbors are out of reach for now.
And honestly, each of those possibilities tells us something new, not just about the cosmos, but about our own place in it. Are we early? Are we isolated? Or are we missing some key piece of the puzzle?
What keeps me fascinated is that every answer leads to more questions. It's not just about finding aliens, it's about exploring the edges of what we know and pushing those boundaries further and further.
So as we wrap up, let's crystallize what we've uncovered today. First, life is way more adaptable than we ever assumed. It can thrive in places we thought were impossible.
Second, the universe might be packed with potential habitats, but finding the right clues like water, the right chemicals, or biosignatures takes patience and cutting-edge tools.
And third, astrobiology isn't just about aliens. It's about understanding our own past, pushing the boundaries of science, and imagining new futures for life on Earth and far beyond.
Here's your next step. Stay curious. Dive deeper, check out our website for interactive experiments, and be sure to hit follow so you never miss an episode. The search for life is just beginning, and we'll be there each step of the way. See you next time on Stellar Lab.
Life on Earth and far beyond.
Here's your next step. Stay curious. Dive deeper, check out our website for interactive experiments, and be sure to hit follow so you never miss an episode. The search for life is just beginning, and we'll be there each step of the way. See you next time on Stellar Lab.
Walking into a room that is just